Hello everyone, welcome to the video lecture of synchronous motor drive. Myself M. Indumati. Let's start the video lecture. In the first slide, I am just showing the picture of the synchronous motor and the schematic diagram. They clearly mark the parts of the synchronous motor in the schematic diagram. They are stator, frame, rotor, windings, and exciter. In the internal structure, they have marked the point where the DC supply to be given. The DC supply to be given to the synchronous motor in the rotor windings. This is rotor. At the end of the rotor winding, the DC supply should be given. Next, we move on to the introduction of synchronous motor. A general definition of a synchronous motor is in which the rotor normally rotates at the same speed as the revolving field in the machine. The stator is similar to that of induction machine, consists of cylindrical iron frame with windings, usually three-phase, located in slots around the inner periphery, which means the rotor should attain the synchronous speed. In synchronous motor, the magnetic field of the machine can be produced by direct current, which is DC current, in the field winding, so that the stator winding need to provide only a power component of current in phase with the stator voltage. To make it simple, a synchronous electric motor is an AC motor, we all know that, in which at steady state the rotation of the shaft is synchronized with the frequency of the supply current. Then the rotation speed is exactly equal to the integral multiple of a AC cycle. This is the general introduction of synchronous motor. On moving to the next one, why we introducing synchronous motor drive? The answer is synchronous motor drive makes the starting, pull-in and parking process smooth and without any problem. These are the main reason for why we introducing synchronous motor drive. And in this diagram, there are three phases. This is R, this is Y, this is P. And this is the DC supply which is given to the rotor winding ends. Then we are moving to the next slide. Now we are going to see briefly about the starting of synchronous motor. Generally, the synchronous motor are started as normal as induction motor. The rotor of the motor is not given DC supply until when the motor reaches the rotor speed, and then pull-in takes place. Then the motor will start. The another method of starting the synchronous motor drive is by external method, that is external motor. In this method, the rotor of the synchronous motor is rotated by an external motor, and when the speed of the rotor reaches the synchronous speed, the DC field is switched on. That is DC current supplied to the rotor of the synchronous motor, and then pull-in takes place, then the motor will start. These are the overall starting of the synchronous motor. Then next one is pull-in of synchronous motor. When the rotor of the synchronous motor reaches the synchronous speed, then the field supply is switched on. That is, DC current is given to the synchronous motor via rotor windings, and the pull-in process begins. As during switching on the DC supply, due to the phase angle and torque angle, there are various disturbances seen in the motor, and there are several slips of poles of air gap flux is also seen. As the pull-in process is completed, the rotor activates the synchronous speeds. From this, once the pull-in process is completed, then only the motor speed is synchronized. Then the complete pull-in as fast as possible, the DC supply should be switched on at the most favorable angle. These are the overall pull-in process of a synchronous motor. Then next one is barking system of a synchronous motor. As we know, there are three types of barking: regenerative, dynamic, plugging that barking. But for synchronous motor drives, only dynamic braking can be applied. Regenerative braking cannot be applied to them as they need higher speed than the synchronous speed. Dynamic braking is done by disconnecting the motor from the supply and connecting it across a three-phase resistor. These are the simple definition of barking system of a motor. And now we are going to see about the types of synchronous motor. There are different types of synchronous motor. We are going to see the types of synchronous motor based on the way they are excited. First one, non-excited synchronous motor, and another one is current excited synchronous motor. First of all, we are going to see about the non-excited synchronous motor. There are three types of motors. They are hysteresis motor, reluctance motor, permanent synchronous motor, that is PM synchronous motor, which is shown in the figure. First, we are going to see about the hysteresis motor. Hysteresis motor is having cylindrical rotor and works on hysteresis losses induced in the rotor of hardened steel with high retentivity. It is a single-phase motor and its rotor is made of ferromagnetic material with non-magnetic support over the shaft. A hysteresis motor is constructed of 5 main components: stator, single-phase stator winding, rotor, shaft, shading coil. As of no teeth and no winding in a rotor, no mechanical vibration takes place during its operation in hysteresis motor. The main application were seen on the hysteresis motor were sound producing equipment, timing devices, electric clocks. Then next one is reluctance motor. A reluctance motor is a type of electric motor that induces non-permanent magnetic poles on the ferromagnetic rotor. Then the rotor does not have any windings. It generates torque through magnetic reluctance. This is the simplest definition of reluctance motor. Then next one is permanent magnet synchronous motor. In this PMSM, that is permanent magnet synchronous motor, is an AC synchronous motor whose field excitation is provided by permanent magnets and has a sinusoidal back EMF waveforms. However, the stator structure with windings constructed to produce a sinusoidal flux density in the air gap of the machine resembles that of an induction motor, which is known as PM synchronous motor. There are various applications of permanent magnet synchronous motor. Some of them are in robotics, machine tools, actuators, and it is being considered in high power applications such as industrial drives and vehicular propulsion. These are the applications of PM synchronous motor. Then finally we are going to see about the current excited synchronous motor, which is shown in the figure. Current excited synchronous motor need a DC supply to the rotor to generate rotor magnetic field. A direct DC current excited motor has both stator winding as well as rotor winding. They can either have cylindrical rotors or salient pole rotors. These current excited synchronous motor are not self-starting motor. They need damper winding to start the motor to rotate. And finally, these are all my overall presentation on synchronous motor drive. Thanks for watching the video and thank you. Thank you.